So let us discuss more about the concept of deviation of a prism. So let's derive so many things from this. I1, R1, R2 and I2, isn't it? So I will apply Snell's law in this particular surface first of all, and I am assuming that this is placed in air. So this is air, the external surface is air, and the internal surface is made up of glass which has a refractive index of mu. May be glass or may not be glass. Let us say that generally speaking it is mu, depending on the material of the prism. So first of all, if I apply Snell's law over here, it will be 1 sin I1 is equal to mu sin R1, isn't it? So from here, what is R1? R1 is equal to sin inverse, right, 1 by mu sin I1. Right, so R1 is equal to sin inverse of 1 by mu sin I1, and we know that R1 plus R2 is equal to A. So R2 is equal to A minus of R1. So in place of R1, I will plug in this value, that is sin inverse of 1 by mu sin I1. So we started from this, we reached up to here, isn't it? Now I will apply the Snell's law across the second surface, that is refracting surface or the emergent surface. So I will get mu sin R2, in place of R2 I will plug in this value, is equal to 1 sin I2, isn't it? So what is I2 then? I2 is equal to, see, I2 is equal to sin inverse, right? So here there is mu and sin, in place of R2 I will be applying this particular equation here, A minus sin inverse 1 by mu sin I1. So I hope I have made this pretty clear as such. So we have a big bracket also after this, right? So I2 is equal to sin inverse of mu sin R2. In place of R2 I have applied A minus of sin inverse 1 by mu sin I1, right? Now just look at that particular equation that I have made as such here. I have derived this particular equation to show you that I2 can be written in terms of I1. Mu is a constant, right? As long as I don't change my prism, the material of prism remains a constant, the A remains a constant because it is a property of the material, I mean the prism as such. So here mu is a constant, A is a constant, again mu is a constant, and I1 is the only variable. So I2 can be expressed in terms of I1. That is the point that I would like to make very clear over here. And what was the equation for deviation? Deviation was given by delta is equal to I1 plus I2 minus of A. A is a constant, I1 let it be there, and in place of I2 we will substitute this particular big equation. So that means the angle of deviation can be written as a function of I1. It is written as an equation where the only variable is I1. So that is why I will say delta is a function of I1, right? So this is this point that I would like to make it very clear to you. So as I1 changes, the delta will also change, and delta will depend only on I1 as per what the derivation that we have done here. So let us proceed to the graph between delta and I1, because this was asked some years before in the JEE exam. So delta, that is deviation, is equal to I1 plus I2 minus of A, and we proved that in place of I2 I can substitute a big equation which contains only I1 as the variable. Now you can do this experimentally as such. See, it will be very difficult to go into the depth of mathematics to learn what type of curve this will be providing at a medical level if you are preparing for the Neet exam and not for the JEE exam. So I would like to tell you that if we just try to analyze this in the lab, in the physics lab, if you make a lot of values from there, if you do this experiment to know the graph between delta and I1, what happens is that you will get a curve that is somewhat like this, right? So this is how the curve will look like. Because you know delta is dependent on I1 and I2, and now we say that delta is only dependent on I1 because I2 can be represented in terms of I1, and if you do that experimentally you will prove that this is how the curve looks like. So the question that they initially asked in JEE exam was that if you plot this particular delta with I1, if you keep on increasing I1, what will happen to the value of the deviation? As I1 increases, you know that you have seen from this, it is very easy to conclude that the value of delta is keeping on decreasing, isn't it? And then it keeps on going to increase. At the topmost point where no further increase in delta is possible, the maximum deviation condition where the delta is maximum, what is this value of I1? That is another question. So this value of I1 is experimentally proven as I1 is equal to pi by 2. Yes. So when I1 is equal to pi by 2, this is the condition where you have the maximum deviation, right? And this is the minimum deviation condition. The minimum deviation condition means delta is least when it comes to this particular aspect of the graph. And if you do the experiment, and you will see that as per the symmetry itself, which is also very easy to understand, that this is the condition where I1 is equal to I2. So we have two results over here. It was more of a theoretical approach to this. I did not go into so much of depths of mathematics to prove that this is this particular graph. See, this is a graph of something like z is equal to x square plus y square, isn't it? Now z is equal to x square plus y square means that this is a variable. This depends on two individual variables, and this x plus y is equal to another constant. So x and y is equal to a constant, while z is a variable which depends individually on these two variables. Now when you have this kind of a condition, this is the graph that you get, and you have a very similar situation over here, isn't it? I1 and R1, I2 and R2 are linked, R1 plus R2 is equal to a constant, and this delta depends on these two variables as such. So it is just like Z is dependent on two variables. These two variables, when you add, you will get a constant. That is the mathematical approach to show that it is this kind of a graph that is going to come. You can simply remember the shape of the graph. It is a U-shaped graph, but remember that at this point, this is the maximum deviation condition. This is the condition where I1 is equal to 90 degree. So this value on the x-axis is equal to 90 degree, and this is the least minimum deviation condition, that is a symmetrical condition where I1 is equal to I2. So let's derive the equation for each of these conditions separately. Okay. So maximum deviation condition, as I told you from the graph, it was clear that I1 is equal to pi by 2, and as we know, delta is equal to I1 plus I2 minus of a. I am keeping on repeating this so that it gets into your head very easily. So when I1 is equal to pi by 2, I know that R1 is equal to theta c, isn't it? So it is easy to understand. So if this is the triangle, I mean the prism, if I1 is equal to pi by 2, then R1 is equal to theta c, the condition of grazing emergence, the concept of total internal reflection. Before that itself, this is theta c, that is okay, isn't it? Now R1 plus R2 is equal to a, so I can write R2 is equal to a minus of theta c, right? Now what I will do is that from in this position, in the second area, in the second refracting surface, I will be giving the Snell's law. So it is mu sine R2. So in place of that, I will be applying a minus of theta c is equal to 1 sine I2. So I2 is equal to, what is that? Sine inverse mu sine a minus of theta c. Right. So I2 is equal to sine inverse of this particular thing. Now substitute this value for I2 over here. So delta is equal to I1 is equal to 90 degree. So that is pi by 2 plus of sine inverse mu sine a minus of theta c, right? So that is this. Now minus of a is also present over there in the equation. So that is all we can derive, and this is the delta maximum. So this is the equation for maximum deviation. So this can be derived on the spot in the exam. No need to learn this, but understand the concept how I derived this, and if at all a question is asked on that regard, you can use this particular approach to solve those questions over there. Now minimum deviation condition is very simple. This is the most symmetrical condition you can ever think of. So this is the incident ray I1, now this is I2, right, and this is R1 and R2, and this is mu. So in this condition, I say I1 is equal to I2. The graph was at the lowermost point when I1 was equal to I2. Now from Snell's law, I know that I1 is equal to mu sine R1. Sine I1 is equal to mu sine R1, and sine I2 is equal to mu sine R2. So from there I can simply get R1 is equal to R2 itself. So if R1 is equal to R2, I will say that my ray is parallel to the base. So ray is parallel to the base. Base of what? Base of the prism, right? So what is delta? Delta is equal to I1 plus I2 minus of A. I1 is equal to I2, that is equal to I. This is equal to 2I minus of A, right? So this is the equation for the minimum deviation condition. So many questions were asked in all kinds of exams pertaining to the concept of minimum deviation. So let's proceed to the next concept. Okay guys, so minimum deviation condition was I1 is equal to I2, R1 is equal to R2. Since R1 plus R2 is equal to the angle of prism, I will write this as A by 2, and delta is equal to 2I minus of A. Ray is parallel to the base, right? Now we will consider a prism which is a very small prism. I mean to say that in that kind of a prism, the angle of prism is very small. Such a small prism if you consider, then you will have to use some mathematical approximations. That is, 1 sin I1 is equal to mu sin R1. That is easily understood, isn't it? That is just applying Snell's law over the first surface. So when angle is small, sine of that angle is equal to that angle itself. That is a kind of approximation that you take in normally in mathematics whenever we need to discuss these kind of concepts. So for sine I1, since the angle I1 is much smaller, I will write it as I1, that is equal to mu multiplied by R1. Just like that, I can write it as mu times R2 is equal to I2, right? So in place of I1, I will be substituting mu times R1 here, and in place of I2, I will write mu times R2 here. So just substituting this particular equation, these two things in this particular equation, I will get delta is equal to A multiplied by mu minus of 1. So this is a very famous equation that you can apply for solving many questions over there. So in the question will be mentioned, it will be a small prism also, and that is how we will be applying this particular question. So never forget this. This is a very important result that we have obtained by approximating a lot in the terms of physics. So that is all with respect to the concepts of prism as far as the deviation is concerned, and let us solve 1 or 2 questions in this and then proceed to the next topic.